And Dawn, Cupertino is telling me it is 3 o'clock. And so let's get this math party started. What do you think?
That sounds good. Deborah, I see a book on this screen. Can you tell me a little bit about that book?
I can. So just so you know, Dawn and I have been working with a resource called Math Fact Fluency, 60 plus games for and assessment tools to support learning and retention. And it is the foundation of the learning we'll be doing today and also in a session that we are doing tomorrow that isn't required, but it's a great follow-up. So today we build a lot of the foundation and play a couple games. Tomorrow we focus on games. So if we're just putting it out there, if that's interesting, great. If not, watch the recording or move on to something else. That's a cool thing about Hopin. All right?
Perfect.
So we're glad to see you. And one of the things that you might want to know is that we have a document that we use today that has all the resources, and I am putting it in the chat right now. It's also back at the very beginning if you already joined us. It just says my name and there's a document there. And thanks, Dawn. You're showing us what that document looks like. Everything that we have linked and the resources that we use besides Math Fact Fluency are free. Okay, and even chapter 1 of this, we'll talk about where it is for free.
Awesome. So we have the resources. And so
with that, Dawn, you want to introduce yourself to the whole crowd of 38 now?
Absolutely. Welcome, everybody. Glad to have you here. Glad to have you stick around on a sunny afternoon. So we really appreciate you being here. My name is Dawn Sparks. I am a regional math coordinator out of ESD 105, which is housed in Yakima, Washington. But currently you see me from my home office here up in Ellensburg. I've taught for 25 plus years, and now I've been at the ESD for nearly 10. So just love this world of being able to have all that teaching experience and now work in this capacity. So I'm going to pass this over to Deborah. You want to introduce yourself?
I am, but I'm going to say a lot of it is repeated. So as you can tell, looking at the screen, we're kind of a certain age. I've also taught about the same amount of time, and Dawn and I went to our ESDs the very same year. So I'm a regional math coordinator out of ESD 101 in Spokane. I taught mostly middle school, so did Dawn. We've raised our families. We love the work and serving the teachers in our regions. And like we said earlier, Math Fact Fluency is something that we've become passionate about in the last 2 years. And while this isn't a full-on class, it can't be in less than 90 minutes. This is a toe into that pond, and you can reach out, and we have some things on that HyperDoc that if you're interested in pursuing this further, you can reach out to us. So I think with that, Dawn, we're ready to move on.
And I just want to thank everybody for introducing themselves in the chat. Just so you know, we are only going to use the chat. We're not going to use the Q&A. We're not going to use the polls. So if you have something, we do have a moderator who's helping us out behind the scenes. But if you could just stick with the chat, that would be the way that we're going to work with each other today.
And we love you responding in the chat. We're watching it right as we're facilitating. So awesome. We'd like to begin today with a land acknowledgement. And Dawn and I are acknowledging that we gather today on the ancestral homelands of Native tribal nations from across our state. Are there any elders, tribal members, or people who identify as Native or Indigenous in our session that would like to give a land acknowledgement? That would have to be in the chat, okay? You can tell us where you're from, though, when you see yourself on the screen, and you can type us what ancestral lands you're coming from. If you see Spokane on the right over there, I am coming to you today from the lands of the Colville Confederated Tribes. And Dawn, where are you coming from?
Well, I'm coming from the lands of the Yakama Nation, and so really proud to be part of that really, really large land mass. And I'm up in the Ellensburg area, but there were different bands that populate that whole region.
Yep. So please join Dawn and I in expressing our deepest respect and our gratitude for our Indigenous neighbors, for their enduring care and protection of our shared lands and waterways.
Thanks, Deborah.
Yep. Dawn, you want to kick us off now?
Yep. So before we get started, I love in today's session, we unfortunately don't get to see your faces and have that personal interaction, but we do have the chat, and we do expect to have a lot of participation today, and hope that you feel comfortable using that chat and chatting right along with us. We are going to play some games, so you're going to have to choose either Team Deb or Team Dawn and help us do some thinking through that chat. So anything you can do to help us with that participation, we'd really appreciate that. And then the top one, I'd like to really think about grace. We have all been kind of thrust the last couple of years into new teaching situations, and I know everybody's trying their hardest, and you know what, we might have a link that's not quite right. Just check with us, let us know. We'll get it fixed up. But if you could show us some grace along the way, we really would appreciate that. And just hope that can-do spirit, folks. We just want you to be participating with us and willing to try new things. So with that, we're going to think about Deborah and I have been doing a lot of professional learning together, and that's been our COVID gift, is that chance to be able to see each other and to work across boundary lines and work together. And the more we work together, the more we have resonated around what we call our core beliefs, and everything that we do fits somewhere in these 3 bullets. So I'll give you a minute to look at that and just think about how that you feel about those as well. That first one, we want to work really, really hard at that notion with students and teachers to really think about fast doesn't mean good. That we want to de-link that idea that just because you're fast at something doesn't mean that you're better at it. We want people to think deeply about the mathematics, and sometimes that takes more time, and we really like to value that time, that think space in a person's head. So we want to de-link that idea of speed being good, that we should never judge somebody's math ability on speed. We also set things up in a way that we want to have students and teachers and really all math learners have to have a little grit in the game. Like if things come easy, then it's not really a problem. It's not a challenge. It's not my brain firing. So we want to make sure that what we do inspires a little math confidence through that idea of perseverance and grit. Now, the last one, we're going to think about games quite a bit. And when we're thinking about games, we are not talking about taking a worksheet and just putting it onto an electronic platform. What we're really thinking about is providing our students with games that math is the center, it's the engine of what we're doing. And also we want to think about how is their student choice in those games? Like, how can I make something and be able to use strategies as we're talking through? The last thing we want to think about is we don't want to do games that take forever to explain. We want to have a game that's pretty simple, pretty quick, and we get kids learning right away. They may fumble, they may make mistakes, but we consider those learning opportunities, and we want to think about how we can use that, not win or lose, but win or learn. So what can I do the next time? But it's kind of simple to get into. So those are our core beliefs. Deborah, is there anything you want to add on to that?
No, I think, Dawn, you've covered those so fluidly. And again, we didn't start out with this. This has been an evolution for you and I over the last couple years, and then getting to facilitate because of COVID getting to work together. So thanks.
Awesome. Okay, so moving on. Our path today. Deborah, I think I'm going to hand that over to you.
All righty, I can do that. So we just want to lay out what's going to happen in the next hour. We are going to look at a math game and an activity, and actually a couple of them. We're going to really dig into thinking about a common understanding of fluency in our work that we do consistently, because we do workshops based on this book. We find and not that we don't all have the same understanding of what fluency is. So we'll dig into that a bit. This book is based on 5 fundamentals for fluency. You will see that. And it's on your HyperDoc in a couple different places. And then we're going to share with you a suggested math fact progression. So for example, when Dawn and I were growing up a few years ago, and we were in elementary school, we learned our 1s, we learned our 2s, we learned our 3s. When I'm thinking about multiplication, okay? We learned our 1s facts, our 2s facts, our 3s facts, our 4s. We went right in order, chronological order. Turns out that there's a better way that lends itself to strategies and making sense of what's happening with the numbers. So we'll be sharing that with you today. Okay, and I think that, Dawn, brings us to our very first thing we're going to ask folks to do. And this is where you would want a piece of any scratch paper that you have, if you have it handy. And the reason we are asking you to have a piece of scratch paper and some writing instrument handy is that we know the importance of having a more common understanding of what fluency is. Because if we don't know what fluency is, I love the Yogi Berra quote. It says, if you don't know where you're going to end up someplace else. And that is so true, not only with math facts, but with everything else we teach. So I want you to take a minute, and my voice is going to get quiet. There's not a spelling test. We're not grammar correcting. Just 2 questions to answer. What's your definition of fluency? Okay. And why is it so hard to be fluent with math facts? Okay. About 30 seconds. Jot that down on your sticky note. So as our 30 seconds is coming to an end, if you haven't quite finished, that's okay. We want you to hold on to this sticky note. Okay. We're going to do a couple things, and then we want you to revisit your initial thinking. Okay. We're not out anybody, just initial thinking about fluency. Right, Dawn?
Well, it kind of sounds like we're going to make our definitions stronger and clearer as we go forward. Is that right, Deborah?
Yes, we are.
Awesome.
And with that, we've been talking a bit. So now, Dawn, I think it's about time to play a game, don't you?
Of course. And this game comes from that book. And not only are we using it because it comes from the book, but we also find that it's a really good game to support kids with their math fact acquisition. We want it to be a challenge. We want kids to have some perseverance and really play with things. And this game does that. So what we're going to be doing, and we'll be showing this in a minute, is we're going to flip over 7 cards. Now, you don't have to use cards. You could use 7 dice. They could either be 6-sided dice, or they could be 10-sided dice. Whatever dice that you happen to use, you can use. You can also use that deck of cards. And I have a deck of cards here. And what I need to do is I need to take out the jacks and the kings. And then the aces become 1s, and the queens become zeros. Mm-hmm. So what we're going to do is we'll flip over 7 cards, and what we're going to do is we're going to add up our total. But that's 7 cards. If I can make combinations of 10 in there, then what I get to do is I get to erase that from my total. And so my total is going to be the total number minus all my groups of 10s. And so we're going to play several rounds. And what you're going to need to do is think about the winner this time is the one with the lowest score. So Deborah and I are going to play kind of kind of just a contrived round. We were going to ask you in the chat to think about how you would score this next one, and then we'll play a couple rounds, and you're going to get a chance to choose teams here in a minute. So here's a sample game. I went to one of my favorite sites. It's randomcardgenerator.org. It's awesome. We'll show you that resource here in a minute. But I want to think about if I could only make groups of 10 using exactly 2 cards, what would my score be and what can I do?
So Dawn, you're wanting us to type that in the chat, right?
Is anybody, this is a chance for everybody to think about that. What would my score be if I totaled up all my cards, but I took out combinations of 10? What would my final score be?
Ooh.
We have a score of 14 that's popped in. And one of the things that I would tell my children in my class would say, is that right? And I would say, sure. Well, now we're getting several 14s, so this is feeling a little bit better now. A 24 and a 14. And I am wondering, Debbie, should we try to problem solve and think about how they got 14? What do you think?
So Linnea says she ended up with 7 and 5 and 2. And I want to think about how she might have done that. So Dawn, I see that there's a 10 of spades and a queen of hearts. So those two could pair up, and that's 10 out, correct?
Right. So if I could put a big old X on these two, I could, but I don't.
Right. We can't this time.
Yeah.
And then I see a 7 of hearts, and I'm thinking Linnea might have done this, a 7 of hearts or the 7 of spades and the 3 of clubs. Because you and I, as experienced mathematicians, we know that 7 and 3 is a 10. When we subtract those out, it leaves, Linnea told us, a 7, a 5, and a 2.
Okay.
So then we could add those and we would come up with a score of 14. Oh. And we've just modeled, I see those bullets right there. We identified the combinations of 10. And we calculated the total score after the 10s were erased. And we talked out, because we can't, we're not going to unmute people and have them share their thinking today. Typing that much out is kind of arduous, and we don't get to play the games. So, Dawn.
Right.
Are we ready?
I think so. So that was our practice round. So now we have a really important question to ask. We're going to be playing a game. And we're going to have 2 teams playing, player 1, team 1, and player 2, team 2. Well, Deborah's going to be on one team, and I'm going to be on another team. And we were trying to come up with good team names, and we utterly failed at that. So we would love to hear what a good team name would be for Deborah. What would be a good team name for Dawn? Let's put that in the chat as well. So what's a fun name that we can be?
There you go. And you're out of present mode.
All right, waiting for some good names coming up.
Because I put in Deborah to be a placeholder for right now so we can get the party started.
All right.
The game started.
I'm waiting for a good team name. Who's on my team? Little Debbie's.
Oh,
Oh, that's brilliant.
Oh, I like that. Math Warrior 1 and Math Warrior 2.
Okay, that's really good. Dawn, the Age of Victory. I love it. I'm going with that. Dawn, the Age of Victory, because we know that we're going to win, right?
Oh, I also like Mathletes 1 and 2, Mary Lou. I love that kind of stuff. Okay. It's not that the others aren't good. I'm just, okay.
What are we going with?
We can just go with these. Let's get playing. We can always change them later on.
Right. So, okay. So in this, this is actually an interactive Google slide, which we have used. And we have a copy of this, and we'll show you where this is. But we're going to use the random card generator, which is super cool. And what I can do is we want to draw 7 cards. We want to have all of our suits. We want to get rid of the jacks and the kings. And then we want to draw those cards and keep the others face down. So this is going to be Team Dawn's set, right? Because Team Dawn's in column 1. So here's our cards. And I think what I can do is I can move this off to the side so that we can see 2 things at once. I think I can do this. I think I could do this. Move this a little smaller. This takes a little conniving, but I think we'll get there. All right.
And we address all of that. We just can't teach every single step right here, but you can reach out to us and we're happy to support you.
All right. So I have a lot of cards here. Anybody got some combinations of 10 for me?
Wow.
Oh, heavens.
Huh.
Oh, that is like the nastiest ever.
I am loving it.
I can't even add that high. Yes, I can. But all right, you guys, help me out. What's my total? Because I see no combinations of 10. The only way I find a combination of 10 is if I can use some subtraction, and I don't know that that's in our wheelhouse yet.
Okay.
So,
well, Dawn, I see a 10.
Okay.
And I know 8 and 7 are 15, so I'm up to 25.
Okay.
And then I know I'm at 25, and I'm going to add my 5 and 6. That's 11. So I go from 25 to 36, right?
Well, I'm going to do it different. So here's 25 and another 5. That's 30, right? And then what's left over is 15. So I think I've got 45.
Okay.
45. Going with 45. Anybody else? The ace is worth 1. Did I get that right?
Ace is worth 1.
45. Okay, we got a couple 45, so we're going with that. All right.
Yep.
So now it's Deborah's turn. Now remember, it's on Team Dawn. We're kind of in a hole right now because we're going for the lowest score, not the highest score. But I'm thinking of this as a learning situation.
But Dawn, can I ask you something? Your total was 45, but you had 110. So don't you get to subtract it, erase it out?
But only if I get 2 cards.
Oh, see, I would be kind to you even in this. Okay.
Takes 2 cards. So.
Okay.
All right, here you go.
Give me some cards, sister.
Here's your cards. Do you see them?
Yes. Soon I will. There we go. Oh, thank you. I love that you dealt these cards. Okay, people. What's the total? My numbers are a little easier to add up.
Well, I'm seeing an 8 and a 2. That's 110.
Yep.
I don't see any other group combinations of 10.
Neither do I. So that means we're going to have to add up everything but 10, correct?
Correct.
Okay. So what's my total, people? It looks like I have a 6 and a 3 and a 3 and an 8 and a 10. Yep, I got 32. So I can do that, my dear. Oh, well.
Oh, yes, you can.
Yeah, that's okay.
Okay, we could change the rules a little bit, Deborah.
We could say that, okay, I'd be happy to, because there's choice in this game, right?
Right.
I think if you get a 10, it gets to count.
How about 3 cards? Could I add 3 cards and make a group of 10?
We could.
Okay, let's try that. It's adding more than 2 cards, or it doesn't have to be 2 cards. It could be any amount of cards, as long as we get 10.
Okay.
All right.
Any amount, I heard you say any amount of cards and a 10.
Okay.
Okay, here we go.
Man, these big cards are horrible.
Well, at least you got 110.
What is my 10? And I would ask students that. What is the 10 that you see popping out? What do you see?
Well, are you asking me to answer this now out loud for real? Okay, I see a 10 of hearts. I also see, yeah, Sarah put in their 110 card. Does anybody see other combinations? Type it in.
Ooh, 6 and 4. Oh, this is looking better.
The 6 of spades and the 4 of clubs.
All right.
Right? So what does that leave us with?
Okay, so that leaves me a 9, 2 7s, and an 8.
Okay.
So I have 15. And I'm going to go with 25. And I'm going to take one away. That's 24. And 7, I'm thinking 31 this time.
That's what I got too. I did it a different way, but I got 31 as well.
And Deborah and I are talking this way because we want kids to like share their strategies for adding, and we're avoiding paper pencil by using some tricks that we know. Not tricks, but that idea that when I add a 9, it's like adding a 10, I just take one off. So that's actually a strategy that they use in this book. I'm pretending a 10. So, all right, Deborah.
So Dawn, you did say, it paper and pencil, but we're demonstrating how this can actually happen virtually. And you already pointed this out once before. We could actually play this in a classroom, in person, using either our dice or our decks of cards, right? That we've preloaded in a bag for the kids, taking out the kings, taking out the jacks, and you could easily have kids recording in a math notebook, right? Or make a quick handout.
And with real cards, you can move them around too. So it kind of separates it out. So it gives kids a little bit more, I can take this away, but add all of this left.
So one of our Dawn's and my goals is to show you that you could do this regardless if you are 6 inches, 6 feet, 6 miles apart when kids are playing these games. These are also great for at home, and we'll come back to that.
All right, Deborah, you're going to love these cards.
Okay. Wow.
Help us out, people. How many points should little Debbie's get?
Yeah, let's just skip over pulling out the tell us what you think the total score is. Just skip to that. Ooh, Matt's saying I got a total of 7. I like that. Oh, yay, they agree. So this is where I get to enter my total of 7. Because it's a Google Interactive slide, Dawn and I can do that. Okay?
Hey, one more round and then oh, look at how big they are again. Oh my goodness. But I'm seeing some hope here. Can we use subtraction yet?
We didn't agree to that yet.
Okay, but we could in the future, right?
We could in the future.
All right. Folks, give us a score. What's the score for Dawn, the Age of Victory? Which I love that name. I'm going to really use that forever.
Yeah, you people don't know what you've done to me now.
You're
naming me Little Debbie and her Dawn, the Age of Victory.
All right.
Kate.
32. That's still not looking good. Well, 32. All right, one more round for Team Deb here.
Oh, yes. Okay, total score. I'm calculating right now. I hope you guys are too. I think it's 13. Yeah, I agree with everybody. It's 13. Yes.
Okay, put your score in there.
You get it. Go ahead.
All right. So this random card generator is just super cool. And if it's not on your HyperDoc, we'll put that on there because it's free. You don't get pop-ups. It's wonderful if you need
and it is on the HyperDoc.
Yeah. And if
right in the game.
If you're wanting to have your kids not use a lot of 7s, 8s, and 9s, you can get rid of those. You can use just smaller numbers. So you can manipulate that which is awesome as well. So, well, there we go. First game. Erase.
Yep. So, Dawn, this was a great fun activity, but what do you think? Was there a little more to this than just you and I having fun together?
Well, I'm hoping there is. We want our kids to have that enjoyable, sustainable practice, but we also want to have things be that that learning situation. So, my job, if this were in the classroom, what I would be doing is walking around and really listening for kids' strategy. And one of the things that I would be doing is I would be pairing two kids against two kids. And the reason I do that is because then kids have to verbalize what they're actually saying and what their actual thinking is out loud. And so I can tune in and listen to that. We love Dan Finkel, and he is awesome. He runs a company called Math for Love. He's got a great video on what makes a good math game. These are his 3 nuggets. And I'm wondering, in that game, was math the engine of the game? I would say check. Yes, it was. Was there choice? Kinda. I could move cards around the way we want to. And then also, after the first round, we rearranged the rules a little bit so that it gave us even more chances to get 10. So that gave us a little choice there. And really, it was pretty quick and easy to play. Mm-hmm. So this would fit our criteria of being a good game. Deborah, you want to add on to that at all?
Yeah, it doesn't mean, Dawn, you did such an eloquent job of describing that. It doesn't mean that every single game you and I choose for fluency meets all of those to the highest standard, but every game that we're using with students to help develop fluency, we are putting it through that filter and making choices. And by that, I mean, yes, I agree with you. Math was the engine of the game. With choice, we made more choices when you could choose to use any number of cards. And then you pose the question, have we gone to subtraction yet? That would also increase the choice and the strategy use. So we start out with a basic game, teach people how to play it, and then we incorporated in this specific game more high-level choices. It isn't about simply calculating the answer.
Thanks, Deborah. That was awesome. We'll be playing another game at the end, so we'll still have our teams. Hopefully you enjoyed that. We wish that we could have you play that, and generally we do, but in this situation we can't. Deborah, I see this beautiful waterfall and math minutes. What's going on with the waterfall here?
So we've already introduced our people to a waterfall chat, and there are some benefits of that. One answer doesn't hang out there for everyone to see or to make it uncomfortable. And the other thing is the quick calculator doesn't drop their answer in and then the thinking goes off for other people. We use it strategically, not all the time. So we're going to talk about some math myths, and we're going to utilize the waterfall chat strategy. So the reason that we want in this session today to talk about math myths is we know in our practice, and I'm sure you've run into this as well, there are some long-held beliefs that people have about math fact fluency. Turns out we have a ton of research from decades and decades and decades that kind of refutes some of that. So we're going to engage in something that can be done with parents at a back-to-school night, at a family math night, at whatever event you're hosting and throwing out a little bit of math. Okay, this is a way to kind of dispel some myths, clarify, and also maybe pique some interest. So with that, Dawn, will you take us to the next slide?
Yes.
So here's the deal. There are 3 statements up here. 2 of them are true and 1 is a myth. So hang on. Remember, it's waterfall chat. So think about this. Possible myth. Statement number 1. Children eventually need to be automatic with their facts, coming up with an answer in about 3 seconds. Statement number 2. Memorization is the best technique to master the basic facts. Or statement number 3. The order in which the basic facts are learned matters. Take about 10 seconds, decide which one is the myth because the other 2 are true, and put that number in chat, but don't enter until I ask you to, okay?
Hey, Deb, really quick, while people are thinking about this, I forgot to ask you guys to turn on closed captioning. So can we do that really quick?
Yes, if we knew how to do that.
I bet it's in the settings down below.
Okay, let me look. Don't see that. A little leery about this now. I don't see it,
What I'll
Eric.
do, Deb, is I will text you instructions.
Okay.
That way you can get right back to your presentation.
Okay, thanks, Eric. Okay, so go ahead and type your answer in the chat now, and we'll get that waterfall going. And you guys listened really, really well, I think, because I'm seeing some consistency in that response. So far, I think I've only seen 2s. Okay, so Dawn, should we go on to the next one?
Well, let's see if they're right. How's that?
Oh, we should do that first, because of course our slide is ready.
Yeah, you were right. Okay.
Yes. Memorization is the best technique is a myth, okay? Our students, when they're memorizing facts, they are losing out on the opportunity to really learn what's going on with the numbers. Okay. Statement number 1, time tests. Remember, hold on to your answer here a minute. Time tests help students master the facts. Or number 2, basic fact fluency is an essential skill for performing operations with fractions. Or number 3, calculators can support students in learning basic facts. Which one is the myth? Hang on to it, type it, but don't enter. Okay, go ahead and hit enter. Ooh.
Oops.
Okay, that's right. It's okay. The myth is time tests help students master facts. I want you to think about this for just a minute. Time tests. Okay, because Dawn and I both did this in our former, before we knew what we know now, we well-intentioned, okay? We gave timed math fact tests to our students. Here's the deal that we became aware of. When we set that timer and everybody has that sheet, whether it's 50 or 100 problems, the only evidence we really have is of an answer, correct or incorrect. It doesn't tell us where they are in their fluency. It only shows us if they can get an answer. Right, Dawn?
Correct. And also, the other thing is if you're spending a lot of time getting your kids to learn a strategy, like pretend to 10, like if I'm going to do 9 plus 7, I could say that's 10 plus 7, 17, and I take 1 away. That takes more time in a student's brain than just to have that memorization. If kids are forced into timing, then they abandon all the strategies that they're practicing, and they go right back to kind of their kind of just reflex brain. And so we want kids to have that time to be able to think things through.
Good point, Dawn. Should we go on to our next myth? Okay, last myth. Number 1, automaticity is the same thing as mastery. Or number 2, using strategies is important in becoming fast with basic math facts. Or number 3, games are not adequate substitutes for fact drill. Take about 10 seconds. I'll invite you to enter. What's the last myth? Go ahead and enter.
Oh, I'm seeing some 1s and 3s. Couple. What do we got here?
So what do we have? So the myth is that games are not adequate substitutes for fact drill, because games that have strategy and have math as the engine of the game are an adequate substitute for fact drills that we have. And you know what? We love that people chose the other numbers because this is what you want to happen. You want to pique people's interest and say, I want to know. Yeah, and it could be just that you misread it. Michelle, thanks for putting that in the chat. That's okay. It's totally, this is not a test, remember? Okay, so with that, that's one way that we start supporting fluency is by reaching out to our colleagues and parents and helping them understand about some long-held myths, okay? And Jennifer will answer your question in just a minute, don't you think, Dawn? Let's go ahead and go on a little bit because Jennifer, hold on to that. We've allowed time at the end to have a question and answer session, and I'm remembering yours right now, okay? So with that, Dawn, let's go ahead and remember back that we had you use a sticky note of some sort, and they were supposed to write down their thinking around fluency. Wasn't that it?
Mm-hmm.
And so now, what are you going to have us do right here?
So we're going to be watching one of our favorite mathematicians who's thought very deeply about fluency. Her name is Christina Tondevald, and she has a lot of great resources out, and some of you may be familiar with her. We're going to add on to the definition, and we're going to watch a little bit of this video. We want you to think about what's not in your definition and what you could add to it, making that definition a little bit stronger and clearer as we go forward. So with that, we're not going to watch the whole thing, but it's linked on your HyperDoc, and you're going to really want to maybe take some time and watch this at some point. So we tested this earlier. It should work. So here we go.
So we've all seen kids who can memorize and regurgitate math facts and solve multi-digit problems using algorithms with what looks like ease. But then you ask them to solve a problem like 100 minus 98, and they have to set it up using the algorithm. I'm Christina Tondevald, the recovering traditionalist, and today we are going to talk about how fast does not mean fluent in our quest to build our math minds so we can build the math minds of our students. Now, I get why we all have this sense of associating the word fluent with fast. It is even in the Common Core progressions. When you look into that document, they talk about how when they use the term fluent in the standards, that means fast and accurate. Now, they go on to describe how kids are using some facts that they just know, they're using patterns, they're using strategies, but they do use that term fast and accurate. Plus, almost all assessments we have for mathematics are assessing those two things. Are the kids fast and are they accurate? But that's really not what fluency is all about. Sure, those are two parts of being fluent, but the third part, which is honestly the most important part, is about flexibility. Oh man, I was that kid who, when I grew up, I could regurgitate my math facts. I knew them memorized. I could solve any problem you wanted as long as I had an algorithm to be able to solve it. But when you would give me a contextual problem, like a word problem, I would shut down. If you asked me to solve it mentally, I really did not have any other way except the algorithm. Like I needed paper and pencil. I wanted to stack problems in my head to solve it mentally. I did not have any flexibility. If I knew it from memory or I knew the procedure to be able to solve it, I was fine. I was golden. But when it was a unique problem or one that I didn't instantly know the answer to, I would shut down. And there are so many kids who are the same way. And there are so many adults that had those same reactions, but in a bad way because they weren't able to memorize their facts. They weren't able to remember these procedures and use them with fluency. And I totally just used air quotes there, but you can see these comments from people inside of the Build Math Minds Facebook group about how when we are focused on that fast and accurate piece through time tests, through multiple problem worksheets, where we are focusing on just getting kids faster and more accurate, it really makes them feel like they are not good at math. And so if it is harmful for just one student, is that really something we want to continue doing? Sometimes we are pushing this fast and accurate piece because we have that pressure of the testing that we have to get kids towards. Or in our standards, we see that term fluent. Every grade level from kindergarten to sixth grade has at least one standard that uses the word fluent or fluently. And so often we have associated where it says fluent.
Oh, the sound went away.
Anymore as a replacement for fluent. What really makes someone fluent is fast and accurate, but also that flexibility in all things in our life. If we do not have all three of those, we are not truly fluent. I want you to take a moment and think about something you are fluent in, and then something you are not in your personal life. It doesn't have to be reading, it doesn't have to be math, okay? It needs to be something in your personal life. I'm gonna give you an example of one that I am not fluent in. I am not a fluent chef. I am fast and I am accurate when I'm cooking. I am quick with what I'm doing and I can follow a recipe to a T. But I am not technically fluent because the thing I lack is flexibility. If I see a recipe and I am missing one of those ingredients, I cannot make that recipe. I'm also not the kind of chef who looks at the recipe and says, oh, if I just add a little bit of this or a little bit of this, it would make it so much better. I am not that kind of chef. So I am not a fluent chef. I can cook, but I have to follow a recipe. And the same thing is true in all of our things in life. We are not truly fluent unless we have that third piece of being flexible. I've heard a scenario of learning another language. Like if you are fluent in another language, it's not just about how fast you are. Yeah, you do need to be accurate and you want to be fast so you can speak fluently. But the other piece of being fluent in a language is being flexible and knowing when to use certain words and in what situations. I could say words in French, but am I using them in the right instances? That's a big piece of that flexibility. So I want you to be able to see it beyond just mathematics, that flexibility piece is really, really important. But so much of the instruction that we do in mathematics is very well intentioned, right? We are doing the best we can with the knowledge we have at the time to help our students. And I know that if I had a struggling student or if one of my own personal kids was struggling, I would do anything in my power to help them. But sometimes we just don't know what to try. And so we're left with these ideas and activities that have been around a while, but are sometimes harmful for our students. So I've created this little infographic that I want you to share out there about what it actually means to be building fluency. What are the kinds of activities that we do that build fluency? And what are the things that we're doing that do not build fluency? Now, do not feel bad if you have done things that are in the column of the does not build fluency, because I have done every single one of these things. They were all, again, well-intentioned. I was doing the best that I could for my students with the knowledge I had at the time. But when I became well-informed,
Sorry, Deborah.
That's okay.
I'm going to stop it there. So
Okay.
hang on for 1 second.
So while you do that,
Along with my well intentions, things change dramatically for me as a teacher and me personally as a learner of mathematics. So I want you to share this out, but I'm also going to talk just really briefly about each one of these. And I'm sharing 10 alternatives. This is not meant to be an end-all be-all document. This document is meant to be the start of a conversation. So what I would really love to see is to have you share this out and then make a comment about what you would add onto this. Do you see something out of this document that's maybe not on there? What would you like to see added into it? It's the start of a conversation, not the end of the conversation. All right.
Okay, I think we want to stop it there. So
I think so too. You got it stopped perfectly because you just heard Christina say, this is just the start of a conversation, not the end. And that is so true. And this is where we'd like you to take a second and think about the things that she just said, and then think about your definition of fluency that you jotted down on your piece of paper. And it could be different. You could have some questions now, right? You could say, want to think about that. That's okay, because this is the start of a conversation, not the end. But we want to be developing that idea, a common idea of what fluency is and how we're going to work towards it. Because otherwise we won't get there. Because if we don't know where we're working towards, we will not get there. It's so unlikely. You want to add anything to that, Dawn?
no, I think, on the next slide,
Yes.
it has some of those things that she talked about. So we're going to leave this up because you might look at that left-hand side and think about, what is in your definition, and, what are some things that, I'm like Christina, done everything on that right side. I have done it all. And so I loved how she said, but now we're more well-informed, and now we can shift our practice. It was the best that we knew at the time. And my Mad Minute book, that I thought I was doing really good things with that I let it go, as I learned things too. So we'd love for you to put in the chat, what's something, if we went back, just tell us a little bit of your definition that you really are resonating around now. So we'll give you a minute and just go ahead and hit enter as you're typing when you're finished. We'll give you a minute to pause on that. For me, it was the flexibility. And the great question from Mary Lou, what does it look like in math fact acquisition? So, I'm thinking about something like 8 plus 7. Well, there's a lot of flexibility on how I could answer that question. Like I might know my doubles and take one away. But then also, if I've got those math facts and strategies down, then can I do 18 plus 7 and use that same kind of idea? Like, well, 8 plus 8 is 16, so it's going to be 26. I'm going to take one away, so now it's 27. So I can use that in there. So we're seeing a couple responses come in. We're going to give you a chance to look through some of that.
Yeah, Dawn, I love that you highlighted flexibility, because the example that you gave of 8 plus 7 is like Christina Tondevold reading the recipe out of the recipe book. It's the basic. It's where we start. And then as she would become a more fluent chef, going on to 18 plus 27 or 318 plus 227, she would have the flexibility to know when she could still use those strategies and when it's not efficient, right?
And I want to just say thank you, Matt, for putting down what you wrote, because I think everybody in the room probably at some point has done something like that.
Me too.
And parents kind of expect it.
Yes.
So one of the things that we do in our longer class is really look at the parent aspect of that and think about how we could change our messaging around for parents. So like, yes, that's one way of practicing, but we're going to try some new things that research is showing makes it more, it will stick. Because being a former 6th grade teacher, I had to go back and reteach facts because we moved our kids through that process too fast.
And Dawn, Paige has a comment here that she says, you know, being patient because kids, and she makes a statement, math, especially for those who struggle, they're all different and at different paces, and we couldn't agree with you more. I want to ask a question though. If there were any middle school or high school teachers in here, they know this to be true. Dawn's smiling at me already. Sometimes, quite often, our fast, accurate kids know how to calculate really quick, but they're not flexible in their thinking.
Mm-hmm.
And so when they come up to something that is foreign to them in later grades, they don't have the flexibility of number to apply strategies that they used in a new situation. So I agree with you completely, Paige, that kids who struggle need this. But I'm going to say that there's a fair number of the kids who seem to be on the surface very capable at math or very fast and accurate, and they also need this.
Right. There's such good comments. I'm looking at Mary Lou's and really thinking about how long does it take to get a math fact? It depends on the child. And if kids aren't getting them, move it to the more concrete. The more concrete you can make it, do it with visuals, things like 10 frames and counters. When we're looking at 8 plus 7, having 2 10 frames up there with 8 in one and 7 in the other, and kids can actually see it and manipulate it is amazing for kids. And then getting that visual clue helps them to move forward with those things so a little quicker. So it takes time, and I think we're going to talk about that soon, aren't we, Deborah?
We are, and I'm going to comment on one other thing, and then we need to move on, or we'll miss part of today's, a bigger chunk of today's session. Somebody asked the question, how do I assess? And that's really something that's in the book. We don't get into that today, but I will tell you this. It doesn't use timed math fact tests at all. We use observation, we use fact checks, we use some other journal writing, and we ask kids how they solve problems. And again, all of those are coming out of here and another place, because there's a companion site for this book. I believe it's linked on your HyperDoc, okay? The book title is on the HyperDoc as well. It's called Math Back Fluency, 60 plus games and assessment tools. All of the assessments are in here. On the companion site, they have a few already developed. And again, if we have long, we could go into that. So thanks for your questions. And Dawn, let's talk about that. Could you go back just a minute? Because one of the things that we want to think about is, do you remember, Dawn, when we talked about, both you and I used traditional flashcards? And you know what? I noticed that comes from the side where fluency doesn't come from. But on the other side, it says interactive and visual flashcards. So one of the things is understanding what that is. So I have a baggie right here, and these are from UCube, Joe Bowler's site, and there's a different set of interactive flashcards. And another thing that literally just came out, and Dawn mentioned our friend Dan Finkel, here's another version, multiplication by heart. They're different, they're interactive flashcards. Graham Fletcher also has some. So what we just want to point out right here, because we don't have time to show you all of those in this 1 hour, is just that not all flashcards are created equal. Mm-hmm. But with tweaking them, we can still use that. And that's something that parents and friends, family, others can really help us with and support fluency. Thanks, Dawn.
So I think we'll go through this fairly quickly. And you know, I've heard Christina look at this document before, and this idea of procedural fluency is huge. Like there's a lot of layers that go into this. And she talks about when kids learn their math facts in a more traditional way, yes, they can be accurate. Yes, they can be efficient and get it quickly. But what's lacking is that flexibility and being able to apply it into a new situation. And that's where our kids get stuck. And so I hope that you get a chance to listen to all of her videos. She's got some amazing things to say. And we're just glad that we could pop her into our presentation today. So we're going to move ahead and think about the 5 fundamentals. And Deborah, I think I'm going to pass that to you, and you can share those big ideas.
You bet. So again, and this shows the book again, so you'll have an idea of what you're looking for when you go to Amazon, because people are asking what book it is. The author, Jennifer Bay Williams and Gina Kling, say that fact fluency is based on 5 fundamentals. Number 1, mastery must focus on fluency. Okay. Number 2, fluency develops in 3 phases. And number 3, foundational facts must precede derived facts. I notice those are in bold. So I know that means we're going to talk about those a little bit more in just a minute. There are 2 others that we won't be addressing today. Timed tests do not assess fluency, and students need substantial and enjoyable practice. Now, if you want to get started thinking about this, but you don't have the book yet, on your HyperDoc, there is a link to an online sample of chapter 1 of this book. So that is a resource for you to look at and be able to see what those 5 fundamentals are. This slide deck is also linked on that HyperDoc, and you'll see this. And then, of course, there's the companion site that we mentioned before, and it's linked. I think, Dawn, that will lead us into talking about some fluencies by grade level.
Right. So all grade levels have some fluencies, and some of them we want to have like pretty firm by the time they leave. And I'm thinking like at the end of 3rd grade, all of the kids should have their multiplication facts and their multiplication division facts. But besides memorizing, and Christina talked about this as well, there are some times we want kids to just be fluent, be able to do it quick, efficiently, and be able to use a strategy, and also think about when one strategy is more important than another strategy. And so really these things are throughout. We want kids to not know numbers so well that when they're dividing fractions in 6th grade, like if I have 1/2 times 1/4, that we know what that means, and that we can really think about, I have a half and now I want 1/4 of that. So what am I going to end up having? We want kids to have that really great number sense and be able to play and manipulate with numbers. So this is one standard that I really like, this standard. And I want you to think about what's something in here that really kind of sticks out to you. And one word, just put one word in the chat, or a phrase. It could be a couple of words.
Don't have to wait. No waterfall.
Go ahead and just put it in there.
Read the standard and what stands out.
Place value, relationships. Oh, I'm loving these people. They're coming. Strategies.
Strategies and strategies.
The relationship between adding and subtracting. You know what? I like to also point out there's a word in here that's not in here. You know what word's not in here, Deborah?
I do, Dawn. It's on the title of that slide. It's the word algorithm. It's nowhere there.
Yeah.
So, Dawn, does that mean that in 2nd grade, no 2nd grader, according to Common Core, is expected to be using an algorithm yet?
In fact, I've known some 2nd grade teachers, wonderful people, but they teach them the algorithm. They're like, I just showed them the algorithm because their parents showed them, and now they get the right answer.
Right.
We've missed out on that whole idea of developing that place value and providing opportunities to play with numbers back and forth. Now, a 2-digit number in 2nd grade is built from having a really good foundation with math facts at younger ages. So it kind of all builds together. We have a couple slides, and you see this clock, because what I want you to do is think about what's happening with this set of standards through time. So as I go into third grade, then I'm adding numbers up to 1,000. I'm starting to introduce the idea of an algorithm, but it doesn't have to look like the standard algorithm, because every culture has kind of a different way that they look at this. And it's not till fourth grade that kids really have to have that really fluid understanding of how to use the algorithm in a consistent way over time. So yes, we have time to develop these big ideas, and that comes from that basis of math fact fluency, that now if I can decompose 8 and 7, and I can decompose the 7 into 2 and 5, then all of a sudden I can do that when I'm adding a number like this. I want you to think about this one. Oh, the undo. I just saw your word undo, Jessica, and it's like, yes, we have to, and I've heard people talk about this before, we have to rewire our brains so that we can teach in a different way. Now, I want you to think about this for a minute. We're not going to spend a ton of time on here, but if you had no paper, you had no pencil, you only had strategies, what are some ways that we could actually solve this problem without using a standard algorithm? Go ahead and put that in the chat as well, because there's a lot of good ideas that we can use here. Add the 10s, add the 1s, add them together. Absolutely. Thank you, Jessica. Okay, take that 7 and 5, add the 12.
Look at all those strategies.
I know. So you guys are using your flexibility here, and that's what we want kids to be able to do. We want to have that built-in flexibility. So like Christina said, we don't have 101 take away 99 and kids are setting it up with the standard algorithm. We have some strategies to use. So very nice. Deborah, you talked about the research that
I did, Dawn. And I'm also scrolling back to Jessica's post that you referenced a minute ago. And it says, the biggest hurdle I'm discovering now after distance learning is it's hard to undo what was done. It's the next sentence that really resonates with me. I loved the parental support during distance learning, but it was so hard to explain to my third graders why we're doing it in multiple ways when they've been taught, okay, to get the answer, the easy way to calculate. But you know what, Jessica? Our parents don't know any different. So they just don't know the reasoning behind it at all. But there's things we can do, like Mythbusters, like many other things that are described in this book, that we can do to help build that bridge for parents and have them know that there are quick and easy games they can play with their student that support that thinking. So Dawn, you bring it up. We talked about the research, and this boils down to, throughout this session, we talk about strategies or memorization, and these are 3 things that I think are important to know. First of all, strategy groups outperform non-strategy groups on post assessments. So you've done something, okay, and you did the pre-assessment, you engaged in something, and then you do a post assessment. The kids or the groups who focused on strategies to get there way outperform the memorizers. Okay. Number 2, strategy groups retain them better because, of course, and Donna and I have talked about this, they've developed that number sense, that flexibility, knowing how to, oh, wait a minute. If I know my doubles, 5 plus 5, gosh, 5 plus 6 is doubles plus 1. They can do that and recall it better. The research, there's quite a body of research on that. And lastly, strategy use predicts success in math achievement in general, meaning all the way through the highest levels of mathematics, kids who use strategies, learners who do strategies, includes ourselves, are more successful. And we know this is true. Again, if there are any middle school or high school math teachers in here, they'll tell you the kids who remember their facts and are more successful in math use strategies. So we wanted to call that out. It's a tool that you might want to use either in your building, on a grade level team, or with parents. And with that, we want to give the due credit to Jennifer Bay Williams for putting this together and sharing that research. And one of the things that she calls out is, while all of those bullets are important reasons, okay, we need to change math because of standards or assessments or our district policy or research says, those are all great things. However, the best and the only reason to really change and teach math facts more effectively is because it better meets the needs of our students. And we all know that in our hearts, okay? And when we're changing for that reason, it will take care of standards and it will take care of assessments because that'll be embedded. And it will address district policy because district policy in some way, shape, or form wants student growth and they want kids to be successful. And then there is research, but it shouldn't be solely based on research.
Thanks, Deborah.
Yeah.
Very quickly, because we don't have a ton of time left, but there was one myth where everybody put 1, and it's that idea that we want to get to that mastery, that automatic place. And this does come. It comes with time. And so math fact fluency really talks about that math fact acquisition and retention goes through 3 phases. Kids start by counting things. So like I might have 7 and I'm going to add 2 more. Well, then I start at 7, I go 8, 9. Or I'm multiplying, like 3 times 5 is 5, 10, 15. That's where the kids start with. They start with some kind of counting additive strategy. And then we get to that point where kids are learning some different strategies and they're reasoning through those. Finally, we get to that point where kids can get that automatic answer. And the difference between phase 2 and phase 3 is that ability to do it very quickly. Like I know the strategy so well, I can just quickly get to an answer. My example is 9 plus 8. I just say 10 plus 8, 18, take away 1 is 17. I know it that quick. So even though it's a strategy, it's taken me to some practice time over some time, but now I know it so well, I don't have to think about it. I can just quickly use that strategy. So it does take time. So the 3 phases. Deborah, we want to talk about this super brief, right?
Yes, super briefly. I want you to look at, because this is on your HyperDoc. It's a handout and you have access to this graphic. But for just 30 seconds, I want you to look at the one on the right. And again, I told you about Dawn and I learned our 1's facts, 2's facts, 3's facts. But this graphic shows and delineates the foundational facts from the derived fact sets. And I noticed that 2's, 10's, and 5's are my first foundational facts, meaning I really have to spend time, like you just talked about, Dawn, to get those down. Then I can think about the 1's and the 0's and the squares because I see that just a little lower down on that graphic. And then finally, when I look below there, we get to derived fact strategies, the doubling, break apart, and all those other strategies. Really super important. And there's one also there for addition and subtraction. Again, check your HyperDoc because that lives there and you have access to it all the time.
Right. And in Jennifer's book, she has games for foundational facts. She has games for derived facts. And so, not just going through the sequence of doing your 1's and then the 2's, like Deborah said, really rethinking what facts I'm going to do first, spend a lot of time on those because it's amazing. If you cull out all of the foundational facts, there's not that many derived facts left. And so having that really strong piece is a really good place to go. Deborah, I don't know. Do we have time to play very, 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 very quickly this game?
I think very, very, very quickly we do because we should show them an extra because I believe we linked a link that they can create this instantly on their own and have the math game. Okay? So we're going to play a game called Squares Bingo. And it just takes a 10-sided die or playing cards, 15 counters, and a 5x5 game board on to start with. And we're going to roll the number, and then we're going to, Squares Bingo, you're going to multiply it by that. It's a square number, correct, Dawn?
Correct.
Is that right?
Yep.
Okay, so I'll get on that slide too, and I know that Dawn has our dice there. So she's going to roll the die. We're going to multiply that number by itself. So in other words, if Dawn rolls a 5, she's going to multiply it by 5 and get that answer. And then move one of those counters. And again, this is bingo, a bingo type card. So she's going for, you know, a bingo. You could change it and play for blackout. It doesn't matter. Okay, Dawn.
All right. We can't retype names on here because it's a picture in the background, not a movable type. So anyhow, here we go. I'm going to change the dice, and I'm going to change it to something that's blue here. And I'm going to throw this dice. And I got a 4. So I can take one of my red dots, and I'm going to do 4 times 4. So I'm going to choose 16. And sometimes there's more than one 16, but I'm going to put mine there.
Ooh, so I hear you say choice and strategy, right? Mm-hmm. And if we had more time, I would, if I'm the teacher wandering by, 2 students playing this game, I'm asking, so how did you know 4 times 4 is 16? We're not going to do that right now, but that is what we're doing. Okay. So, thanks for rolling for me, Dawn. What did I get?
An 8.
Oh, 8. And I know that 8 times 8 is 64. So I'm going to grab a die, and I am going to, and there's more than one option here. I'm just going to drop it there so you can roll again for you.
And you get the point. We want to get 5 in a row. Is that correct?
Mm-hmm.
We want to get a whole bingo.
You want to get a bingo vertically, horizontally.
0. So we don't have a 0 on here. So we're going to make this a 10. And 10 times 10 is my 100. So I've got a couple choices. And I'm going to put that here. I think they get the point of this, Deborah. So yep. This idea that you can play games, have kids talk, again, play 2 against 2. So they have to verbalize.
And once again, we've designed this for virtual learning. But I have these bingo cards already made up and laminated, and I use them in classrooms with teachers with dry erase pens so that they can get used over and over. And that was even during COVID because schools on my side of the state were open. We just had to disinfect them. So with that, we're going to thank you because we know at 4:25 this shuts down. And you get to go on to another session. And we want to be able to address a couple questions right now at the end. Isn't that right, Dawn?
That's right. Question and answer period. So, and I see we still have 52 people on here. So you people are stuck with this awesome, well, this is just awesome. You guys stayed with and didn't pop out. So thank you for that.
Yeah, thank you so much. Now,
hey, Deborah, do we have a follow-up class on tomorrow?
Oh, we do have a follow-up to this where we get to do even more games and we share them with you again. It is listed on your HyperDoc, I think, but it's at noon tomorrow. So if you're interested, great. If you're not, you feel like you got enough, go enjoy another session. Dawn, can we go back to Jennifer's question? Because I promised her we'd come back to it. Her question was, what about programs like Rocket Math that provide different goals for different abilities? Because I did use Rocket Math at one point.
So can I, because I never used Rocket Math, so I'd like to add my 2 cents worth first.
Okay.
First of all, one of the things that's missing from this is it's more than just games. In Math Fact Acquisition, we use quick looks, we use story context, we use games, we do them all together. We want kids to see it visually. We want them to be able to hear things like, there are 4 ducks on the pond and 2 more show up. How many more do we have? And so Rocket Math, I don't know if it has those other components that's really building that more of that whole jigsaw picture, or if they're just going after the math fact. And that's what I don't know because I don't know the program.
Well, you know that I've been out of the classroom for a few years. When I used Rocket Math, there wasn't a focus on strategy development in the program. And what I struggled with was the third grader who I knew had number sense, and she could not do it quickly enough when the timer started. It was the timer that bothered her. It wasn't about the math. It was about the timer starting. And so I will admit this because I no longer work there. I turned off the timer for everybody. And all the kids started doing better. It was just like I was finding out more things. And again, it shouldn't be our core beliefs, and the authors and the growing body of research says don't attach it to timing. Kids can get really efficient at strategies and answer effectively and accurately within 3 seconds. That is considered being fluent. Dawn, we had another question. I answered HyperDocs. If you're looking for it, scroll up, or I just posted it in there because, again, all of our emails are on there. All of the links to everything we used is here today. And one other person, there was a question I saw, and it was from Andrea. Is there a continuum of learning for math? And I said, do you mean for math facts? Because that's our focus today. And that's when I talk about a continuum, that's that graphic, Andrea. And the one on the left was addition and subtraction. And the one on the right was multiplication and division. On your HyperDoc, there is a link to that document and a few others that come directly from Jennifer Bay Williams. And she did a session during NCTM's 100 Days of Professional Development. And she shared that. So it's widely shared and dispersed. And we have about 2 more minutes. If there's a burning question, put it in the chat right now because there's still 43. Thanks, Dawn, for scrolling through that so they know what we're talking about. This is, I mean, it tells the 5 fundamentals. It's just awesome, which is why we, Harry Wong, steal. We didn't steal it. She made it available, right? And we love it.
I love the idea of the IEPs. Yes. So, if you know, like, okay, if I know my doubles, then I know next I can work on near doubles, and that's my next goal. That's awesome. Like, if I can get through my 2s, 5s, and 10 facts, then I can work on squares, and then I can start to work with break apart strategies. So that's awesome.
Hey, 2 questions, Dawn, that just popped in. What will our session be on tomorrow? It's just on games. We skip over. We did foundations today, so we skip right to games. And second thing, is the PowerPoint available? It is on the HyperDoc. It's linked.
It's at the top, and it says Google Slides, and they're right there.
And it'll be the same thing tomorrow. I mean, we'll have a HyperDoc for tomorrow's resources, which will be different than today's.
Well, thank you both.
You're welcome.